So I'm going to talk about why this is important. You showed up to the talk, so presumably you're already a little bit sold on why it's important, but hopefully I can make you even more excited for the rest of the talk because no one's laughing at my shitty jokes yet. So we need to up the energy level a bit. I'll do a quick look at testing. This focus is on validation, but I'm going to talk about how testing and validation compare together. We'll look at sort of the limitations with validation for data pipelines and distributed systems, and we'll talk about what people do, what people have tried to do and hasn't worked, and we'll talk about some tools. And we'll also talk about the special challenges that you get when you're trying to validate a black box ML model. And there will be lots of pictures of cats. And I actually think I accidentally deleted this slide with a panda, so this promise is a lie. There are only cat pictures. I'm very sorry. It's what happens when you change things at the last minute. So I'm hoping you're all nice people. I'm actually really curious. How many people here are familiar with Scala? Oh, thank God. Okay. How many people are Java developers? Cool. And any Python developers in the house? Wonderful, wonderful. Is there anyone who is none of those languages? I'm sorry. Random person in the back. The examples today are in a mixture of Scala, Java, and Python. Definitely feel free to stop me and I can explain any of the syntax which doesn't make sense. And I'm also actually really curious, how many people are Spark users or familiar with Spark? Okay. And let's do that again for Beam. That's, okay, 5 people. Oh, 6, yay. Okay, that's fine. So even if you don't use Spark or Beam, these same techniques will be generally applicable to other things. The examples are with Spark and Beam, but if you're using other systems, that's totally okay too. Ooh, clicky things. So why should we test? It makes us a better person. It avoids making, it avoids making our users angry, and we can save money on AWS or Google Cloud or whoever it is that we're buying our compute time from. And I think the last one is, or not the last one, this one is really the main thing. The development cycle with testing our full pipeline is really annoying, so that's why we test, so that we can get feedback faster. So why should we validate? So we should validate because our tests aren't going to be perfect. Even if we spend tons and tons of engineering time on tests, eventually we're going to fuck up or screw up, whatever. And we want to know when things have gone poorly so that we can avoid showing our users that we did a bad job. We want to hide our failures from our end users and pretend that our software works. So we want to be able to halt deployment and roll back. And even if we can't do that, I don't want to be woken up at 3 a.m. by a page from someone telling me I have 20 minutes to fix an issue because a customer is on the line with them. That is one of the things which I never want to do again in my life. Right, here we go. So this is 36% of people automatically deploy the results of their big data jobs into production. If you don't have tests or validation and you're automatically deploying the results into production, that is terrifying. Relatedly, about probably half of the people who automatically deploy the results, 15.3% of people, have experienced a serious production outage as the result of their Spark jobs. And I imagine the percentage is similar for other systems as well. Spark may be a little bit higher, and a solid 30% of people didn't have a serious outage, which means no, I didn't have to update my resume, but we did return only cat pictures for about a day and a half. So that's okay. And then 52% of people are really lucky. And hoping that you're in this part of the world where you're really lucky is not a good strategy, right? You have to accept that eventually things are going to go wrong, and the best we can do is catch them quickly. So this is why we don't test. mostly we're lazy and distributed systems are hard. They make it harder to test, and we tell ourselves that it's totally okay, I tested it in local mode. And that's like saying, no, 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 it's totally fine. I rode a bicycle once. I can ride 1000cc Kawasaki. That's gonna go perfectly fine. It's not. Yeah, the other reason why we don't test is how many people use notebooks? Cool, I love notebooks. Testing notebooks sucks. Like, they are not designed really in a way that facilitates good development practices. And so why don't we validate? I think it's similar. It's a lot of work. We can convince ourselves that our tests are good enough, right? That could be true. And the other one is, what could go wrong? Like, what's the worst case scenario for my distributed data pipeline? I used to think this. I built a recommendation system at a company, and I was like, worst case scenario, we make some wrong recommendations. That's fine. That was not fine. We'll talk about that in a little bit. And the other one is distributed systems make it harder. It's not like we can just connect like to JMX and ask like, hey, what's going on? We have 100 different JMXs. The other one is our code becomes a little less deterministic because we have to expect failures on our cluster. And so the presence of some failures is pretty much just going to be life. And so I can't just stop when one thing goes wrong. I have to like try and recover, but also to figure out when I'm getting too many errors, and figuring out when I have too many errors is pretty hard. So what happens when we don't test or validate? So once upon a time, I worked at a retailer of fine goods and less fine goods. And we built this cool recommendation system. And this recommendation system was really cool. But then some data changed on us. And it got confused about the meaning of a word. And this is a word which had both a very happy, innocent meaning, totally safe for like small children to type in to the internet and expect happy results. The word also meant something else, and we put in safeguards, right? Because we realized that our computer could do bad things. But then the safeguards broke when the data changed because we picked some random thresholds, and we're like, that's fine. This looks fine. And then it started recommending things. And then I had 20 minutes to fix it. It wasn't 3 a.m. that time. It was 6 p.m. And the only reason I had 20 minutes is someone gave me a call and was like, listen, I'm giving you a 5-minute heads up before I file the official ticket. You need to fix this. And so that was really stressful, right? Like when you're like, oh shit, I don't know how to quantify how bad what I've just done is, right? Like, you have to fix the problem, and you don't know if you have a job tomorrow, right? That's not good. My resume was nowhere near as solid as it is now. I couldn't just be like, not my problem. I'm going to go like to monster.com and start filling out some applications. Later on, at another glorious company that I worked for, we had a schema change, and we weren't doing schema validation, and so we just stopped doing any recommendations. And we didn't notice because we were lazy and we didn't have any validation. And that cost us a few $1 million in lost revenue. That was an awkward conversation to have as well. Still had a job though. And the last time is, I learned that recommendation systems can do illegal things. And that was a thing that I didn't want to learn. And you probably don't want to think too closely about this. But we almost recommended illegal content to people. And this was not a place where we sold stuff, but it still would have been really bad. And I didn't want to be the person who found out if I was legally responsible for what my computer was doing. That's not fun. Like, that's a question for other people to find out, right? Make safeguards so you don't have to deal with these problems. Okay, cool. So hopefully you're either excited or terrified, and one way or another, you'll pay attention to the rest of the slides, which is why we have this cat here who is paying a lot of attention. Okay, so simple unit tests in Spark look a lot like normal unit tests. This is totally fine. The point of this is that we can write simple tests in Spark. The fact that it's a distributed system is not an excuse for not testing your software. Admittedly, we have to use a library. This one is Spark Testing Base, but there are other libraries that do similar things. And if you happen to be one of the 6 Beam users who were in the house, your life is even easier because it's built into Beam itself, and you can write these assertions here and have similar unit tests. And these run in local mode normally. And this is the part where, yeah, I mean, we can write simple unit tests, but they're not good enough, right? Like, if I test on 3 elements, I'm probably not going to know if my thing is going to handle big data scale, right? This unit test is not really going to guarantee that this is going to work. So even if I have nice unit tests, I need to go beyond that. All right, and there's a bunch of things we can do to get data for our tests. And there's this other thing where it goes, hey, I can come up with 3 examples by hand. That's kind of cool, but that's like a lot of work, and I'm really lazy. What about if I ask the computer to generate examples for me? And then it turns out Scala check, which is inspired by quick check, and there's similar things in other languages, can actually generate our data for us. And so then what happens is we say, hey, what's up? Generate arbitrary distributed collections of strings for me. And on all of those, make sure that when I apply this operation, the counts are the same, right? We would not expect this to change the counts. And if it did, something would have gone very wrong. And we can do it for a lot more complex logic. We can say things like, if I'm parsing records, you know, I would expect to have less records than my input because I was going to reject some of them. And so it doesn't have to just be equality. And we can use it for 1 million elements. Okay, Dr. Evil did make it to this side of the room, but not that side of the room. So you need to watch Dr. Evil. It's a really good show. Okay, so, and this can be slow, and it's sad, and there's a bunch of things you can do to make it faster, whatever. Not overly important. Let's focus on validation, the reason we're all here. And so testing is great, but we need to go beyond that. So how do we validate it? There's a bunch of things that we can do. And the idea is that at some point, you've made a data pipeline that worked, right? Like, validation isn't going to be able to tell us, like, unit test style, if what we're doing is correct at all from a starting point. What we're looking to do is we're looking to see if the world has changed in a way that my software is no longer correct, assuming that I started at least kind of working. And this is really important because a lot of us write pipelines which run every night. Or if they don't run every night, we run them once every quarter when someone yells at us. And by then, like 6 things have changed rather than 1. And we don't know if it's important. So I want to be clear, validation does not replace your initial manual testing. It's about making sure that your assumptions still hold. So there's a bunch of things that we can do. We can collect a bunch of metrics about our pipeline, and we can try and see if these metrics are changing in ways where historically they haven't, right? So if we have like a number of input records, if it starts decreasing, unless we're working at a company which is failing, we would probably expect our user table to be going up. And if it went down, that is sad, and we should probably not make recommendations today. We should come in, take a look, see if the user table is actually decreased, update our resume, or if the user table hasn't decreased, update our pipeline to be correct. Or I mean, maybe you did like some filtering out of spam bots and then everything's fine. You don't have to update your resume. You just like click accept. Just like GDPR and hit go. Sorry. And we can write these rules in a bunch of different ways. We can have simple counters for things which we would expect to be above absolute values, but we can also think about things like over the last 10 runs, or over the last year, or today should be similar to what today was 1 year ago, right? If I work in retail, like I have seasonal trends that I expect to sort of follow. And we can write our rules to look at these counters and see what's happening. And there's a lot of built-in counters, but the built-in counters often don't tell us the whole story. So sometimes we're going to have to add our own counters. And we'll look at this, and we'll look at why it sucks, especially in distributed systems, but we'll make it better. No, clicky. There we go. So rules for making validation rules. Right now, the really depressing thing is what most people end up doing is they check their file input sizes and they check their file output sizes. And if it looks kind of like yesterday, they say, okay. And that is better than nothing. But it is still not very good. And we'll look at other things that we can do. Spark Validator is a package which allows you to write these rules more easily. And one of the things that you can do is if you've done property-based testing, you can actually use some of those property-based tests to write validation rules. So if we think back to this thing where we were saying the number of results should not have changed through this operation, we can have a validation rule which says, like, the number of inputs I had should be equal to the number of outputs for this thing, and we can look at the counters for that. We'll talk about why the counters are not perfect. Oh, right, and the other thing that I want to make really clear about validation rules is these aren't tests, right? I think, personally, it's okay if your validation rules are sometimes wrong, right? This talk is not going super well, so it's not likely that everyone's going to go and sign up for Google Data Proc. But if you all did, we might have a validation rule that said, like, hey, what's up? Like, the user growth should be within X%. And we might break that, and that's okay. We would stop the pipeline. We would avoid making any business decisions until we went back and said, yeah, it's okay. We just had a whole bunch of new signups. It's not that something's gone wrong with our data. It's okay, just run it. And so I think it's okay for these things not to be perfect. Because if we hold ourselves to perfection, we're just not going to be able to catch nearly as many things as we need to. Input schema validation. So as you've noticed, there's a lot of cat pictures, but it turns out cat can mean two things. And if I get heavy equipment cat, my pipeline, which pets the cats and tells them that they're really, really pretty cats, is probably not going to go very well because that's 700 pounds. And it will crush me. So I need to know when I get the wrong type of cat. And more generally, this is when my data type has changed. And if you're working in a small company, this might not be a thing which you're overly concerned about. You might be like, I know all of my data sources. I know everyone who works on them. It's totally fine. Nothing will change without me knowing. And that could be true for now, but almost certainly you work with outside companies. And those outside companies will probably not remember to tell you every time they change their data schema. I don't know if you've ever had an API break unexpectedly on you, but think of this as having an API break unexpectedly. And the importance is we should catch this rather than just producing garbage. And there's some things that we can do. We can write explicit flat map or filter stages to go in and check for things that we expect to see in our input data. If you happen to be a Spark user, you can specify a case class of what your data should look like and tell Spark, hey, try and make it look like this case class. And that's pretty okay, except for the part where it throws a really hard to understand Java exception, but it works pretty well. And the other one is you can just manually specify your schema on the input side. In both Beam and Spark, you can specify what your data should look like in the reading layer. And yeah, essentially the cases where you won't have your input schema eventually change on you are where you're working on CAG. And so we go ahead and we say, hey, what's up? How many times did we divide by 0? And then it says, yeah, all of your records, we tried to divide by 0 and failed. And so we would look at this and we would say, that was probably bad. Something is wrong. Right. A more realistic situation, and this one's in Scala, is we make 2 accumulators for the number of OK records, the number of bad records, and then we have some parsing logic in here. And essentially, we want to say, hey, is this valid? If so, yay. If no, ugh. And then we do our work, and then down at the bottom, we're like, hey, what's up? Was more than 10% of our stuff garbage? And if so, tell me. And it says like, yeah, that was bad. Let's not publish these results. And then optional cleanup. So it's really basic. And the only downside is that these accumulators are slightly non-deterministic, which is a great thing to use in flow control. No. Okay. So the point is that occasionally these values will get counted kind of weirdly. And this especially happens if you work on a noisy cluster, or if you're working with like spot instances, or something where some of your nodes might disappear randomly. These numbers might get double or triple counted, but it's okay because we have two accumulators and we tend to double or triple count on a partition basis. So even if we double or triple count, the relative ratio will probably still be okay. And if not, we can just like press run again and see if it works, which is normally what I do when I get an exception. Another one is we could use a library to help us write these rules, and this is using the Spark validator package. And we can say, hey, what's up? I want this records read counter, and this records read is like a Spark counter. This isn't a counter that we defined ourselves, to be between these two numbers. And if it's not, throw an assertion error or do whatever you want to do. And so you have your fancy business logic that goes here and does all of its work, and then afterwards you just make sure that your rules were valid. If you're working in Beam, counters are a little bit different. And the cool thing about counters in Beam is that they behave differently on different systems. That's so exciting. I love things like that. It means I still have a job. And so once again, our special business logic goes after we've made our counters, aka calling Fortran, because Fortran will never die. And we go ahead and we keep track of the number of things that we matched or didn't match or whatever it is that we care about processing, and then we can do our thing with our counters. And this is cool. It's pretty basic. The nice thing, or it's basic in that compared to the Spark version, this works on data flow deterministically. But on Spark, it works non-deterministically because you can run Beam on top of Spark, and you can also run Beam on top of Flink. And on Beam on top of Flink, I have no idea what it does. I couldn't get the demo to work. But that's okay. The TLDR is you can use these, but even though they do appear deterministic, since you probably want the flexibility to move between systems, don't trust them to be deterministic. Just assume that they're bad like Spark, and always do this sort of two-counter thing so that you can do relative rules between the two of them. Another thing that we can look at is the percentage of our data change. And not a lot of people do this, in part because it's really expensive, right? Joins are expensive, and then I also have to keep a copy of my data from yesterday, or however frequently I run my pipeline, and see what it looks like. But this can be really good, right? Especially for things that are not schema changes, right? One of the things that people will do is they'll like try and make a change, they'll see it break someone else's test cases, and then they'll be like, okay, fine. I'm not going to change my schema, I'm just going to change the meaning of this field, because then everything compiles, and that's great, and I can ship it. And that's totally cool. It compiles, they can ship it, they can deploy it on Friday, and on Monday, my pipeline will break. Because the meaning of a field has changed, and so we won't catch it by validating the schema. Instead, we have to look and see if we've had a lot of change. So this would have caught the problem where we were recommending the wrong kind of bunny to people, because we would have seen that we had an unexpected number of rows change. Oh, damn it, I said the word. Anyways, we can look and see at the number of rows which have changed in our input, and if it's really huge today, maybe we should go and talk to Bob, who, promised he would tell us the next time he updated the schema, but maybe he took a very literal view of that statement, right? And we can go and be like, hey, I noticed 80% of my input tables changed. Do you know anything about that? And then they'll be like, oh, well, I deployed this small thing on Friday at 5, but I didn't think anyone would mind. And you're like, yeah, let's have a conversation. And that's where critical communications can come in. Anyways, so this is really expensive to do, but it turns out it's probably less expensive than being sued. And not only is this less expensive than being sued, doing it uses computing resources, which are the thing that I sell you. So I think this is great. I am aware that some of you may not agree, and that is fine. The other one that you can do, which is a little bit less expensive, because normally our outputs are not as big as our inputs, we do some type of aggregation, is we can also look at the percentage change over our output, right? This is similar to the idea of like looking at the size of our output table, but with the idea of like, hey, what's up? If everyone has a new recommendation today, that could be amazing, or that could be the start of a really unfortunate BuzzFeed article, right? And so I wanna take a look and double check that everyone is getting recommended the new blockbuster movie, not something else. The only catch of this is you have to keep an old copy of your output data, but you were doing that to roll back to anyways, right? Everyone's ready to roll back immediately. Okay. And I see 6 people laughing, which means that if they tell me there's ticker symbol, I will not do insider trading. Okay, right. And so that's cool. That's largely about changes in data. How else can things go wrong? So many ways. So we can upgrade Spark, and that's amazing. Or we can upgrade Beam, and that's amazing. Or our cloud provider could upgrade it for us. And that's amazing. Yeah, and that can be really exciting because they'll do things like fix the handling of missing data. And that's really cool until you discover they fixed the handling of missing data by inserting the average value in a column. And all of a sudden, all of the people who had never tried a special part of your site now have tried it an average amount. And that might be unfortunate for your recommendations. And yeah, so that was sad. So if you're going to upgrade your version of whatever tools you depend on, and you just expect it to get faster, not different, please, even if you don't normally check the percentage of data change, do that one time. And by that one time, I mean once every 6 months. If you have a machine learning model, you get all sorts of kind of wonderful things. You upgrade, and then someone tweaked the gradient descent implementation. Just a little bit, because it was so much better on their research paper. And so there's this really wonderful talk, if anyone's really sad about this, or is not yet sad and wishes to be, where they look at, I think it was a decision tree and a few other algorithms over the releases of scikit-learn for the past year, and the performance with the exact same code with different versions. And it wasn't like a strict improvement going up. It was whoop, 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 whoop. And that's not I mean, I probably should have done that as a graph, but even if you can't see the hand gestures, it goes up and down and up and down, and that's probably not the experience that you want to have. So everything else could look fine. You have a new version of your software, everything's looking good, but your results just went to garbage. You don't know why. So that's awesome. So let's focus on the ways that machine learning can combine with this to be even harder to figure out what's going on. We can do a lot of the same things, but some of them probably aren't going to work so well. One of them is our output size is probably not going to be a great indicator of what's going on, right? Like, I can't be like, yes, I still have 6 weights in my linear regression model, and I had 6 weights yesterday, so this is a good model. That is probably not a true statement. The other one is, especially if we're using things like neural networks, eyeballing the results can be a lot harder, right? I can't like sample 6 records and be like, this looks fine. My friend Bob is getting very good recommendations, and that's good. I can look at it and be like, I have 6 weights. They look similar to yesterday's 6 weights. What could go wrong? Or like one of them 0. I hope that wasn't important. So the traditional theory for deploying models is that a human decides it's time to update their models. There's like a new research paper. It's very cool, very fancy. So they're going to go ahead and do that. They go through their update model runbook. They run a few big data jobs to do data prep. They deploy their new model on some percentage of their machines that are used for serving. They stare very intently at some graphs, and then they press deploy, and they take this X, and they replace it with the number 100. In practice, what happens is some of your stakeholders will corner you and be like, listen, you haven't updated your model for a year and a half. I'm pretty sure something has changed. And you're like, yeah, okay, fine. You go and you try and find your run book, but then you realize you didn't write it. Or even better, the person before you didn't write it, so that's cool. You give up and you kind of wing it. And it kind of runs. It spits out a model. You look at the weights, they look okay. You deploy X% of your models, and then you go and you surf the internet for a while. And then you come back, and no one's yelled at you, so it's probably okay, right? If it was really bad, someone would have told you. So you press deploy, and then everyone gets recommendations. Yay! And if that worked, that's great. And often it does, but sometimes it doesn't. So instead, what we do, because we're programmers, is we replace ourselves with computers, because computers are slightly less lazy. So instead, we have our computer kick off our job periodically. It publishes a new model. We have some other things sitting around to notice when a new model is available. It deploys the new model to X% of the population. It looks at some monitoring graphs, and it sees if we look bad. We use statistical tests, also known as this number is lower than this number. That's not so good. I saw that 6 times, so that's really bad. We roll it off, the pager goes off, and a human comes back and presses deploy anyways. Yay! Okay. So the TLDR is we can replace it with we can replace the humans with computers, but at the end of the day, the humans are still going to do bad things, but we can try and give them the information so that they are less inclined to do bad things, right? We could give them the cross-validation performance and be like, hey, not only is our A/B test kind of bad, when we did CV testing, this said it was not very good either. We can have performance against a fixed test set. That has some problems with keeping it up to date. Another one that we can look at is like, hey, what's up? Your model converged really, really quickly today. And that may sound like a good thing, like convergence. Convergence is good. But converged really, really quickly often means my data was zeros, because I can fit a model really quickly to a bunch of zeros. We can also look at other things like the number of features selected. And we can look at the changes in the model weights and kind of guess. Cross-validation is amazing. You should all use it. The only one that I've noticed, which is a little sad, is a lot of people use cross-validation for tuning their hyperparameters. And then at the same time, they take those same numbers and they're like, yes, these are my performance numbers. But all you've done is overfit, but you've hidden it in your hyperparameter tuning. And so you can pretend you're not overfitting, but you're still overfitting, and this will still run like a kind of crappy car. Do you have the Renault Reliance here? No. Okay, do you have a Ford Pinto? Did that ever make it here? It was a car that caught on fire frequently. Mostly when driving, which was not better. So just picture like a really bad car here on fire, and that's your machine learning model. But you'll have some tests that tell you it's amazing. And so that's good when it comes time to have that awkward conversation with your boss. But you still kind of want to avoid that awkward conversation. Click. Yay! Right. So we can get a false sense of security from cross-validation, especially if we're using it for hyperparameter tuning. There are a whole bunch of other things that can go wrong. And I know this is kind of like a footnote, but try not to be evil. If you're making your ML models, it's really easy to use a machine learning model to take a bunch of data about people and then encode that as fact. And really all you're doing is encoding that a bunch of people think this. And that might not be great. But we probably don't have time to fix that in 11 minutes and 27 seconds. So go and learn to be good people somewhere else. It's not my job. Okay, relatedly, once you've trained your machine learning model, you might find that it's really hard to serve. And this becomes really challenging because, right, we want metrics from serving time as well as from training time. Like, I want to know if I'm making a lot of empty recommendations to people, or if I'm recommending the same thing a lot more than I used to be. These are all important metrics that I should have as well. And I don't have a solution for that, but I do have a list of things that have promised to maybe provide a solution at some point in the future. In practice, everyone ends up rewriting this code by hand with only the finest copy and paste Java code known to humans. So that's great. My clicky thing, one of these two might click. Yay, clicky. Okay, this isn't super important. The TLDR is, yeah, eventually you're going to have to update your model. Is anyone doing online machine learning for their models? Oh, there is one person, and we have to have a really sad conversation together. The TLDR is, this gets so much harder. Please checkpoint frequently so you can roll back when things go poorly. Good luck. For the rest of you, you've got like a year, and then you're going to probably have to do this. I'm sorry. Okay, so some ending notes because I ramble a lot. I think it's important that our validation our validation rules do not have to be perfect. And you should definitely always have a way for the human operator to override, especially if you do that first one, because otherwise they'll just keep running that job again and again until it passes. And that's great for me selling you things, but you probably just want a way to mark okay. The other one is, especially if the people deploying your software are different than yourself, be really friendly about the messages. Think about writing them for yourself at 3 a.m. when you're drunk. Because honestly, that's probably who's going to get the page, right? Like, it'll go to someone else, they'll be like, I don't know what this means, and they're going to call you, and it's 3 a.m., and you have to fix it now. Oh, right, and the other one is, so we can make all of these cool rules, and that's awesome, but sometimes people think that because they're making things to make their thing more reliable, they don't have to make tests for that, and that's not true. You have to make tests for your validation rules, otherwise you've just added a whole bunch of new ways for your software to fail unexpectedly. So make sure that they're actually doing what you expect, please. Cool. I'll post these slides because you can't click on the blue links as humans because the glass or whatever demo it is doesn't reveal the URLs yet. If you're interested in open source, I would appreciate you following me on Twitch and YouTube because I do live streams of code reviews that I think are kind of cool and at least 2 other people thought were kind of neat. Oh, I can go back if you want to take a picture. Okay, already done. Excellent. And I'll definitely tweet these slides. There's a bunch of related tools that I've worked on, and some of them that I haven't, that exist in this space. There are other tools as well that I just am less familiar with. And if you're working with Spark, I think these are some pretty okay tools, and you should check them out. In Beam, a lot more of this stuff is integrated into Beam itself, but I still think that we could probably have some cool tools here. Yeah, if you want to copy XML, oh yeah, you can take a photo of this and copy the XML with your phone. If anyone watched I.O., copy and paste into a PR right there. Good to go. Okay, we're getting to the most important slide, and that's this one. I have a book. I actually have another book as well, but I didn't realize you could negotiate royalty payments. And on this one, I did. And so every book covers about 1/4 of a cup of coffee in San Francisco. And you can help save a developer from a life of enterprise support contracts. So don't waste your own money on this, unless it's relevant. But if you have a corporate credit card, I encourage you to buy many copies. Okay, cool. So that's pretty much it. We've got a bit of time for questions, I think. If anyone wants to fill out this survey link, one of the ways that I try and keep this talk up to date is collecting feedback from other people, because sometimes they do cool things that I haven't thought of, and then I can share them with the world. So, question time.
Pedir para fazer as perguntas no microfone, se puderem fazer em inglês, se não se sentirem confortáveis de fazer em inglês, querer fazer em português, eu posso traduzir, tá bom? Perguntas?
Okay.
No
So this
questions?
talk was either amazing or terrible, based on the awkward laugh. Yay, question!
Everyone.
Thank you for fulfilling the awkward silence. I did not bring my tap dancing shoes with me, which is my normal interlude.
Hello, thank you for your talk. It's common to see some bad practices of software engineering inside jobs that was written with Spark or some technology related to your talk. Can you give some tips to avoid this mistake?
Yes. So avoiding these problems completely is really hard. I think at the end of the day, we will always make some mistakes, and the best we can do is try and catch them, right? Like, my code will never be perfect, your code will probably never be perfect, and certainly my coworker's code has definitely never been perfect. Sorry. Oh, there is a camera. Okay. I think code reviews are definitely like a very good social practice as well. I think obviously more tests, as always, help. But at the end of the day, you know, there's social problems, and we're engineers, and we don't excel at solving those often. And so I just want software to tell me when other people have changed things on me, so that I can try and fix it before someone notices. And so I really think making or using tools like this for your pipelines to validate that the schemas and the data has not changed unexpectedly on you is the best we can do. If there's better things, that's cool too, but no one's told me about them.
Mais alguém? No?
Hi. I never watched any kind of live code reviews before, and I'm not even sure if you came up with this idea or you're just like...
Oh, yeah. So the long and short version of it is, as much as I love spending my time on airplanes, I also enjoy not spending my time on airplanes. And I was looking at the metrics for my job, and one of them was like scalable content, and I figured I could call that scalable content because it wasn't defined, and it seemed easier than all of the other ideas I had, which is why I do them more. When I talked about it with some other people in the open source community, there was another project which had started doing them, and they said they found them really useful for getting more people involved in the code review process. And I've also found this in the Spark community as well, is it's a good way to get people who are kind of like on the fence and a little unsure of what to do to feel more welcome and more like the people who are reviewing their code actually really want to help, because we don't want to do all this work ourselves. And I know there's someone in the Kubernetes community who is talking about doing some stuff there as well, but they haven't started yet. But there are a few other people who do this. But the short version of it was that I wanted to do this because I could spend less time on airplanes. And I hope it's useful. But regardless, I get to spend less time on airplanes, so it's useful to me.
So, last one. No? So, thank you very much.
Oh, thank you for having me.